Welcome to section 3.3, tangent lines and the derivative at a point. The learning objectives are following. So we'll define tangent line to the graph of a function and the rate of change, derivative point. So basically there are two different ways to interpret derivative. So one way is by means of the tangent line, so slope of the tangent line, and another one is as a rate of change. So both definitions will agree. Let's start. So tangent line to a graph of function. So I'll kind of start with an example. Let's say that I have a function y is equal to x squared plus 1. And let's say that I want to find a tangent line at x equal to 1. So tangent line in Kazakh, it means ranama. If you sort of roughly sketch the graph, so this is a parabola. When x equal to 0, this is 1. So this is a parabola. Let's pick different color. This is some sort of a parabola like this, right? And I'm looking for x equal to 1. So x equal to 1 is, let's say, somewhere here. And this is supposed to be when x equal to 1. So when x equal to 1, y is equal to 2, right? So this is supposed to be 2. So what is a tangent line? Well, tangent line means you want to sketch a graph of a line, right? Passing from this point, and this is tangent, right? It is tangent, ranama, tangent to the graph, right? It's touching the graph. It's not sort of intersecting the graph at that point. So it's a line, right? So let's say that y is equal to a times x plus b, right? So the question is, what is a, what is b? And if you remember from your high school, a stands for the slope, right? Slope of the slope of this line. Well, what was the definition of the slope? Well, definition of the slope was tangent of the alpha or the angle, right? So there is an angle here, and you want to find this tangent. But what is the tangent? Well, tangent is nothing but this height right here divided by the width, right, for this right triangle. Okay, but how do we find it using our graph? Well, what I can do is I can start with different point, right? I can pick some point right here. Let's call it x, right? And there is y here. And then instead of because I for now don't know, so let's compute this particular the slope of this particular line, right? What is this line? Well, as you can see, this is height, this is the width. If you calculate height, it's y over 2. So the slope of this orange, right? Slope of orange triangle is orange line, if you like. This is y minus 2 divided by this width, which is x minus 1, right? So x minus 1, right? So what happens if I let x approach to 1, right? X could be also less than, but anyway, so we'll come to that also. Then this orange line will approach to the green line that we are looking for, right? The green line that we want. But this orange line will approach, right? If I keep decrease or approaching x to 1, it will slowly approach to this green one. So let's see what's happening, right? So let's try to find out what are the numbers that I'm getting. So I will use the link that I provided there. This is from GeoGebra. So this is the function x squared plus 1 that we are looking for. and I calculate the slope. So green is, in our case, it's orange. Sorry for that. So I'm looking at 1. So what happens? So at this point, like when b is, for example, this x is equal to 2, I get 5 minus 2 over 2 minus 1. That's the slope of this green. But I'm not looking for the slope of the green. I'm looking for the slope that touches the graph, right? But this particular green is intersecting. So what it means is I need to approach, I need to get closer. When I get closer, the green line will approach to the tangent, right? It's approaching to the tangent, right? Uh, Also from negative side, if you approach from negative side, when approach to 1, your green line is approaching to the tangent, right? And then let's look at this slope. So slope on the right. So currently, like it's 3.36. If you divide FP minus FA to B minus A, etc. So when you approach, you see I'm kind of approaching to 2, right? Something like this. But when I'm 1, then this is not, because it doesn't exist, right? For limit, we don't touch. And similarly, if you approach from left, when you get closer to 1, when your b or x gets close to 1, we see that this quotient approaching to, again, 2, right? So it means that this slope is, so this suggests that this slope is 2, right? So this suggests that, let me pick the green or the red. So it means when my x approach to 1, is y minus 2, x minus 1 seems to be approaching to 2. So that's my slope. In fact, we can also calculate it from here, because what is my y? Y is x squared plus 1, right? So this is y minus 2, x minus 1. So this is y x squared plus 1 minus 2, x minus 1. So we see x squared minus 1, x minus 1. Well, this is x minus 1, x plus 1 divided by x minus 1. So luckily x minus 1's cancel, we get x plus 1. But since x is approaching to 1, x plus 1 approach to 2, right? As x plus 1. So this is my slope. In other words, my a is, so let me, where can I write? So which means my a slope is equal to 2. Now what is my b, right? So how do I find my b? So what is the b? Well, I know that this point lies on this tangent line, so which means it needs to satisfy. So when x equal to 1, y is equal to 2. So you substitute into this equation. So 2 is equal to a is 2 times x is 1 plus b, from which we get b is equal to 0 in fact. So which means, a long story short, that the tangent line we got is y is equal to 2x. So in fact, it looks like it's going to pass from the origin, because at x equals 0, y equals 0. Okay. So so that was like an intuition. Now here's the definition of the slope. Slope of the function at point x0 is, you let h go to 0, f of x0 plus h minus f of x0 over h. So this is the slope, if you like, or it's also a derivative um, that will come later for the definition of derivative. But this is also the definition of the derivative. We can say it f prime of x0. So what we did was slightly different here, right? I mean, we don't have h here. Somehow we let x go to 1, not like h go to 0. But this is more or less identical, because what in our case what we did is the following. We said x goes to x0. My x0 was 1. F of x0 plus x. Here I have f of x0 divided by uh, x minus x0, right? This was the case. So you can simply do the substitution. You can do like x minus, if you let x minus x0 equal to h, right? If you make the substitution, then when x goes to x0, right? If x goes to x0, your h goes to 0. So this limit is equal to, with this new change of variable, y goes to h, sorry, h goes to 0. And here what you see is f of x plus x0. So what is f of x0? So here, from here, x 0 plus did I do? Oh, sorry. This is not here. It was supposed to be x. So I made a mistake. Right. So this is so simply x. So then this is what you solve for x. So x is x0 plus h. So here it's going to be f of x plus x0 plus h minus f of x0, and in place of x minus x0 you let h. So that recovers this particular definition, right? So they are identical. So whichever you want, they are identical definitions. Okay, let's do an example, a different example. So let's consider this y is equal to 1 over x at any point, right? So let's assume that my a is somewhere here. Let me pick different color. So my a is somewhere here. And it's not 0. What is the slope? Because at 0 it's not defined, right? What is the slope? Yeah, first I need to find general, and then I need to find what happens x equal to minus. Well, so go back to this particular definition. So what is the slope? Well, slope is the limit as h goes to 0, h, and then here we have f of x plus h, but my f is 1 over, right? It's 1 over x, so this is 1 over x0. So instead of x0 I have a, right? So this is a over h minus then f of x, but f of x is 1 over x0, but x0 is now a. So that's, so I need to calculate this limit. Well, let's see what we get. Let's see what we get. So at the bottom I have h. Here the common denominator is a plus h times a, and the numerator is a minus a plus h. So a is cancelled. What we see is h in there. So h divided by a plus a, and here we have 1 over h. So h is cancelled. So I have some limits there anyway. So this is a limit. H goes to 0 of 1 over a plus h times a. But what is, so if h goes to 0, a plus h goes to a. So this is the numerator is fixed, but denominator goes to a squared, unless we did some mistake. So look at what happens here. If you sketch the slope, this is the angle is with x-axis is more than pi half. So this is tangent of that is negative. So we need to get somewhere negative. So where is the mistake? You see here at the top, a minus h plus a plus h. So when a is cancelled, I get minus h here, right? So this must also be minus h. So it's minus. Now, if you want to calculate what happens at x equal to minus 1, so at x equal to negative 1, the slope is going to be, you simply let a equal to minus 1. So this is minus 1 squared. So this is negative 1. Okay, 1. Okay, where does the slope equal? Minus 1 over 4. So this was a. Now let's answer b. Where does the slope equal, right? So what this means is I already have the slope, right? It's a general formula. So I'm lucky that I found the general formula. So this is asking when I will get minus 4, 1 over 4. So minus is cancelled. We see that this is if and only if a squared equal to 4, but this means a is equal to plus minus 2. So at negative 2 and at positive 2, if you sketch the slope at this point, this slope is going to be minus 1/4. Okay, next. What happens to the tangent line to the curve at the point, right? As a changes. So what is happening? So it's just a qualitative analysis, if you like. So let's say that my a is somewhere here, and this is my slope. What happens if a changes? For example, if I let a increase, what happens? My slope is decreasing, right? It's becoming more horizontal. Horizontal means like it's becoming pi or 0, and the tangent at that point is 0. So horizontal, it means my slope is approaching to 0. And similarly here, right? If I approach to negative, my slope here is so my tangent line becoming more and more horizontal. It means my slope is becoming 0. Okay, how about in the other extreme? What happens if I approach to 0? Right, so let's say that I'm right here, then you see my tangent line is becoming steeper and even steeper. So if I approach, even steeper, and also from negative side, right? If you look at the tangent line, so it's becoming even steeper and steeper. So it means at 0 or near 0, it becomes infinite, right? So slope slopes are so you can say that as a goes to plus minus infinite, slope sort of goes to 0, but as a goes to 0, slope blows up, right? So slope goes to uh, plus minus infinite, I think. So here it's negative, here it's positive. I think it's plus minus infinite, depending on from which side you're approaching. Okay. So far what we saw was interpretation of a derivative as a slope. Another interpretation of derivative is coming from rate of change. So first, let me start with formally defining the derivative. So the derivative of a function at point x0, which we denote by f prime x0, so that's how we read f primes, f prime x0, which is the limit as h goes to 0, f of x0 plus h minus f of x0 divided by h. And as I mentioned before, this is also x goes to x0, f of x minus f of x0 divided by x minus x0. These are equivalent, okay? And the derivative in Kazakh would be tunde, right? Tunde. Okay. Um, so why it's now we want to realize as a rate of change. What do we mean by this, right? So for example, let's say that I have a particle. I have a particle. Let's say it is start at t equal to 0. It was at 0 position, and then it started moving some in one direction. Let's say that moving right? And so this x is changing, right? So x is changing, and I want to find out how this x is changing, right? So let's say that I want to find out how fast is this particle, let's say a car, uh, is moving, right? Moving in this direction. How it's the displacement changing. So within 1 second, let's say. For example, if the speed of the car is 20, it means 20, let's say that meters per second, let's say, then it means within 1 second, the velocity, there is a 20 difference, right? So rate of change is different. So if I think my x is as a displacement, right? Displacement, then what will be the velocity? Well, velocity is it's a rate of change. So it's some rate of change of this x of the displacement. And as you know, the velocity, as you may know, the velocity is nothing but the derivative of x. So we another notation would be dx dt, right? So we'll come to that also. Um, and how do you determine this change? Well, like let's say that per second, right? Within six. So for example, within 1 second of time, right? Within 1 second of time, how do you do it? Let's say that if you're at a position x0, you want to find out what happens within 1 second, right? So what would you do? You would do something like you would compute the displacement, right? So this is t, sorry, t0 and t0 also. So then displacement would be x of t0 plus 1 minus x t0. So that's the change, and you divide by the time lap, right? So which is 1 second, something like that. But if you can like if you want to compute the instantaneous rate of change, it means you need to let your this one could be like your h, right, in 8 seconds. Then you let h go to 0, and that would be your velocity, right? So another way to sort of interpret, long story short, another way to interpret derivative is to realize this as a rate of change. Rate of change. Okay, so let's do one example. Let's say that we can somewhat model COVID active cases, so the number of people getting sick, active, currently sick. Let's say that we can somehow model it with this t cube plus 1, where t represents days. How fast is the number of active cases changing, right? After 100 days. So this is exactly asking the rate of rate of change, right? So it's exactly asking us rate of change when t is equal to 100. Okay, so 100 could be very far away, I don't know, somewhere, and then we want to find out the rate of change, which is also the slope. If this is my f of t equal to t cube plus 1, right? So I want to, in a sense, I want to find out the slope of this function when my t, or if you like, my x is equal to 100. Well, we know how to find the rate of change, right? So this fast, it also means speed, right? So anyway, so rate of change, can be found by a derivative, right? So this is like f prime of 100. If you know how to take the derivative, fine. You probably know it, right? You probably know it. But anyway, let's do it. So h goes to 0. So remember the definition. Instead of x0 here, I have 100. So this is f of 100 plus h minus f of 100 divided by h, right? So that's the answer. That would be the answer if I manage to calculate. Well, what is tq plus 1? So instead of for f, so this is like 100 plus h cube plus 1 minus f of 100 is 100 cube minus 1 divided by h. So minus ones cancel with each other. Now I need to use the binomial expansion, binomial formula. So what is 100 plus h cube, right? So this is 100 cube plus 3 times 100 squared times h plus 3 times 100 times h squared. Finally, h cube minus 100 cube. So luckily 100 cubes cancel. And if you stare at these three variables, I see that h is in common, right? So h can be cancelled out. So this h can be this h, one h of this. So here two will remain, will cancel with the bottom. So then what is left? So let's write it out. H goes to 0. Here this is 3 times 100 squared plus 3 times 100 times h plus h squared. That's it, right? At the bottom, I just have 1. Now, if you let h go to 0, this this term, the second term goes to 0. The third term also goes to 0. So I'm left with 3 times 100 squared. So this is 3 times 10,000, or if you like, this is 30,000. So that's how fast the daily changes. In other words, at day 100, so within 1 day, there will be 30,000 more active cases or sick COVID cases are coming. So that's how you can interpret the rate of change, right? The speed of this function, so the speed of this change is 30,000. I will stop here.